Hi guys, this is Vineet, and in today's video we will talk about preparations required before the query optimization in SQL Server. So we will talk about preparations that are performed before the actual query optimization takes place. Now let's move ahead. There are some points to remember while watching this video. Please watch this video till the end to gain better clarity of the concept, and if it's possible for you, please watch this video twice. Perform any exercises in your lab and test environments only. Do not touch any production environment or production databases. We would like to know your thoughts regarding our videos, so please share your comments with us. Any suggestions you have, you can share it with us. Any requests you have, you can share those with us. And you may also share your day-to-day stories with SQL Server. Maybe you have reaped some benefit. Let me repeat. Maybe you have reaped some benefits after watching my videos. Let us know about that. In case my videos have become beneficial for you under any of the circumstances, do let us know about that. I have created some playlists for you to watch. Links are available in the video description. So I have SQL Server database design playlist, SQL Server table playlist, business continuity playlist, SQL Server indexing playlist, SQL Server Performance Tuning playlist, and SQL Server Integration Services playlist. And if we combine all these playlists, total videos I have on my channel is around 163 videos, and number of videos are growing at a constant pace. So if you are new to this channel, please quickly go ahead and subscribe to my channel. There is a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon and select all notifications to get notifications regarding all my future videos. Apart from that, I have a channel page at youtube.com/@SQL Talks by Vineet. You can visit my channel page and you can subscribe from there as well. Apart from that, you will see the all my playlist over there and all my trending videos over there, so please check out my channel link page. And all these links are included in the video description area of this particular video. Now let's come back to today's topic, which is preparations that are done before query optimization takes place in SQL Server. So let's quickly go to my notes window. So let's talk about query optimizer preparations. So guys, we all know what the query optimizer is. Please watch out my previous videos as well in case you have not. There's a playlist on SQL Server performance tuning which you can watch. So basically, if we talk about query optimizer component in SQL Server, all the performance within the SQL Server starts and ends with the query optimizer. So basically, the work of query optimizer is to create execution plan. That's basically the work of query optimizer, right? Query optimizer prepares the optimization plans. All right. Now, and we all know all the query performance within SQL Server starts and ends with the query optimizer. And query optimizer is very important to the query performance because it creates the performance execution plans. All right, so let's take it as topic and let's take it as let me mark this with black color quickly. All right, so it is also very important for query performance. All right, the query optimizer is very important for query performance. And in this video we will be talking about how your optimizer behaves in order to better understand why our queries behave the way they do. Now let's talk about the optimization process. So we talked about query optimizer that basically creates a query plan for us. So basically, if we talk about the optimization process in general, so let's talk about the optimization process which makes use of the query optimizer as well. I'm making it just bold. Alright. Now the end result of the query optimization process is the end result is a query plan, right? So the query optimization process results in a query plan, not sorry guys. So the optimization process results in a execution plan, not a query plan. So optimization process ends up in a execution plan, and this execution plan shows what choices optimizer has made. Right, if we go through the query execution plan, it will show us what are all the choices that our optimizer has made. And this, if we talk about the query optimization process, this is an expensive process. If we talk about cost of the process, it's an expensive process in terms of resources. And what are these resources? We will say especially it's CPU. Especially CPU is one of the resource. All right. So this is the query optimizer. The optimization process is an expensive process because it consumes the resources, especially the CPU, and it's time consuming as well, right? It takes time to generate the query plan, and basically it also affects the execution time of our queries. Now we will shortly go over what this process is and how the execution plan is generated, and how that plan goes into memory in the plan cache. Alright, so what topics we will talk about? We will talk about how execution plan is generated and how that plan goes into the plan cache, right, in memory, in the hopes of reusing the plans. So plans, the query optimizer generally stores the created plan in the plan cache in the hope of reusing that plan in the future. We'll talk about that. Now we will address the following topics. So first, in this video we will be only covering the query optimization process in general. Optimization process in general. So we will talk about the query optimization process. That also we will complete in the next video. So particularly to this video, if we talk about, we will just talk about the query optimization preparations, not the complete optimization process, but what preparations are done before the actual optimization occurs. So we will talk about that. So let's cover this topic, the query optimization process. So as you can say, this will be the part 1 of this video, and yeah, in part 2 we will cover the actual optimization process. So stay tuned. If you have not already subscribed, please subscribe to my channel. So let's talk about the query optimization process. So if we talk about the query optimizer, right, so query optimizer uses the query optimizer basically generates the query plans or execution plans, right? So query optimizer basically uses a cost-based analysis mechanism to arrive at necessary choices made within the query plan. Or maybe we can say that query optimizer uses it performs a cost-based analysis to arrive at necessary choices made to satisfy the queries we have submitted. Alright. we have submitted. So the role of query optimizer is basically to generate a performance plan, best plan for execution, and it does so by doing a cost-based analysis. Now, if we have to process a particular query, a large number of choices must be made. So, what are those choices? So, if it's say in order to process a query, a large number of choices have to be made by the query optimizer, right? So what will be these choices? So we talk about these choices. Let me further bullet it. So what would be these choices if the query optimizer here has to make a choices in order to process a query? So one of the example is which index to use. It can select which index to use to access the table. This is one of the choices which query optimizer can make. And the second choice could be how to join two tables together in case there are joins we are using in the query. So it can also see, the query optimizer will also see how to join two tables together. Let me take this whole thing in the next page. Alright, so the next thing is the query optimizer make a choice regarding how to join those two tables. First choice was how to use, which index to use to access a particular table, right? And third choice could be whether or not the data has to be ordered. So it also see whether there is a ordering required in the data. So all these choices and many others are all given cost by the optimizer. So optimizer gives cost to all these choices. Whatever choices it makes, it gives the cost to all those choices. Alright, so if you talk about the execution plan, it gives cost to the every step, right? So these steps are all the choices which are made by the query optimizer. We will show you one of the plans shortly. But yeah, if you have seen my earlier videos on the execution plans, you must have some idea about the execution plans. We will show you how to generate one in some time, in maybe 5 to 10 minutes. So stay tuned. So basically, the work of optimizer is to give cost to all these choices in order to access the data from a particular table, right? And if we talk about optimizer is aware of the structure of the database. Whatever database structure we have, optimizer is aware about that, right? So what does this structure include? So this structure includes the data type of your columns, right? And another structure item could be primary key definitions, right? Another item could be constraints, foreign keys, and all these objects, if we talk about all these database structure object, if we talk about, these objects affect the cost estimates as well. So this database structure objects like data type of columns, primary key definition, constraints, and foreign keys that are defined on a particular table, and these affect the cost estimates that basically the optimizer uses arrive at its decisions. So basically the optimizer consider all these things, the structure of a database in order. In addition to that, it also looks into which index to use to access data from a particular table, how to join two tables together, whether or not the data ordering is required. In addition to that, the optimizer is aware about the data structure of the column or the structure of the database, including the data types of a columns, primary key definition, constraint, foreign key, etc. And basically these items, the structure items of a database affects the cost estimates that optimizer uses to arrive at its decisions. So guys, I hope you're taking down the notes as we are going further. Alright, so these four items also add to the cost, right? We have just mentioned. Apart from that, what else add to the cost? So use of statistics, if we talk about statistics about the data. So statistics can be calculated for a particular column in a table, and statistics can be calculated for an index as well, index column as well. So these statistics also add to the cost, also adds to the cost. Alright, we will talk about these statistics later. Now if we talk about the query optimizer, so query optimizer we are talking about all through. So first of all, we have talked that it uses a cost-based analysis mechanism to arrive at necessary choices. So it gives cost to every steps. Basically, it gives cost to performs a cost-based analysis and make necessary choices to satisfy the queries that we have submitted to the query optimizer. And in order for a query optimizer to process the query, it also has to make large number of choices, like which index to be used, how to join tables, whether or not data has to be ordered, and optimizer basically give cost to all these choices. In addition to that, another area where the optimizer give cost to these items is data type of columns, primary key definition, constraints, and foreign keys. And we all know all these database structure objects affects the cost estimates that the optimizer uses to arrive at its decision. Finally, we've talked about that statistics also adds to the cost of the query plan or queries plan steps, I would say, or execution plan steps, I would say. Alright, so let's talk about the optimizer again. So if we talk about optimizer, optimizer does not attempt to make a perfect query plan, perfect execution plan, I would say, not query plan. So if we talk about optimizer, it doesn't make any attempt to make a perfect query plan or perfect execution plan. Instead, what it does is optimizer uses the mathematical models, right? Mathematical models on the objects, and in addition it uses the statistics in our database, right, to arrive at a plan. So query optimizer applies certain mathematical models and it uses the statistics in our database to arrive at an execution plan that is good enough, if not perfect. Give me a minute, guys. So it makes a plan that is good enough for us, though it does not make a perfect plan. And how it makes the plan, it applies the mathematical models and use the statistics in our database to arrive at a good enough plan, I would say. So basically, if we talk about the cost based analysis that the query optimizer uses. It uses that analysis to arrive at an optimal plan. So query optimizer uses cost based analysis to arrive at an good enough plan. Alright, as it can, while using the as few resources as possible and finishing up at as quickly as it can. So let's complete this statement. Query optimizer uses the cost based analysis to arrive at a good enough plan using few resources as it can and finishing up as quickly as it can. Alright, so this is basically the work of the query optimizer. So we are talking about the query optimization process in general, but so far we have discussed the query optimizer. What all items does it use and how it calculates the cost and how it creates the plan? What item does it think of before creating the plan? Alright, and this is done. Now let's talk about the actual optimization preparation process for which we are creating this video. So in this video we will only cover this query optimization process. Alright, and let's see. Now if we talk about the optimizer, it needs so much metadata about your system. As it needs so much metadata about your system, there are number of steps before optimization takes place. So basically if we talk about optimizer, it needs so optimizer needs so much metadata about the system, right? So before the actual optimization can take place, so if we say before the actual optimization that can take place, there is a preparation that is required. So before the actual optimization can take place, there is some preparation that needs to be made to put this information together. Alright, so we will talk about this preparation. So what preparation is required? There are certain steps for this preparation. So one of the steps is, let's talk about this preparation. So first step is in the preparation is the parsing. Second step is binding. Third step is the actual optimization process, which we will cover in the next video. So for this video we will just cover the parsing and binding processes. Alright, so if we talk about parsing and binding, these so if we just talk about the parsing and binding are performed by Algebrizer. This is one of the components which performs the parsing and binding operations. So let me correct the spelling. So Algebrizer is the component which performs the parsing and binding operations on the query data. Alright, so we'll talk. Give me a minute, guys. So if we talk about the steps in general. So I'm not showing you Algebrizer over here, but yeah, process start with parser. We will give you details on each step. So the query is fed to the parser, which basically, so if we say query is fed to parser, and if we talk about parser, it generates the parse tree out of that query text, and then object binding is performed, or binding is performed. So this is basically the steps. So after object binding, I would say the data is then fed to the query processor tree. It basically the object, after object binding, a query processor tree is created. Not, it's not a component but an actual output. So a query processor tree is generated, and that tree is fed to the optimizer component. But for this video we are covering till here. The optimizer we will cover in next video, so stay tuned. If you are new to this channel, please quickly go ahead and subscribe to this channel. So first the query is fed to the parser. So now let's complete this process. So the optimizer, the query processor tree is fed to the optimizer, and optimizer generates the query plan and stores that information in the storage engine. Alright, so this is a general step, and let me go ahead and let's discuss about the topic, which is parsing. Let's cover this off. So if we talk about a query first goes through the relational engine within SQL Server. So a query is first fed to the relational engine within the SQL Server, and this is the first part of two processes that deal with the query. So this Algebrizer and all we were talking about, it's a part of relational engine, and the second part is the storage engine, where optimizer stores the query execution plans. So a query first goes through the relational engine within the SQL Server, and this is the first part of two processes that deal with the query. Now if we talk about the second part, the second part is the storage engine. And what is the responsibility of the storage engine? It helps us in data access, modification, and caching. So the role of storage engine is this: it helps us in accessing data out of tables and all, making modifications to the data in the tables, and perform caching of execution plans, if any. Now if we talk about the relational engine, let's come to a relational engine here. So what's the role of relational engine? It basically takes care of parsing the query through the process called Algebrizer, which we were talking about. So Algebrizer is a process where parsing and binding takes place, and basically it's a part of relational engine process called Algebrizer. So relational engine basically takes care of parsing the query through the process called the Algebrizer. So I hope you got the idea. So the parsing of query is the part of relational engine work, and it's done by a process called Algebrizer. And uh, what's the another role of relational engine? Relational engine also executes the query as per the execution plan. That's another part of the part of work that a relational engine has to perform. So relational engine also executes the query as per the execution plan generated by the query optimizer and requires the data from the storage engine. So storage engine is basically used to access the data from the tables, and all this work is performed by the relational engine, which basically does the parsing work and binding work through the process known as Algebrizer. And second part is the storage engine, where the actual data retrieval takes place. Storage engine helps in retrieving the data out of tables. So all this is a part of big process which is performed by the relational engine. Now let's talk about the Algebrizer, which performs the operation of uh, parsing and binding. So let's talk about this Algebrizer. So it does multiple steps, including the parsing and binding, right? Parsing, by parsing we mean query parsing. So what is the role of parsing? Parsing basically validates that we have. So it basically, the parsing process reads out the query to see whether we have correct syntax within our query. Alright, and if there is an error in the syntax, now if there is an error in the query syntax, right, the process is immediately terminated. So the parsing process is immediately terminated whenever it encounters an error within the query syntax, and all the further optimization processes are interrupted. Alright, if the syntax is not correct, and then all the further optimization process are interrupted or halted, and the total overall parsing process immediately gets terminated if it encounters any syntax error within the query, right? Now here we are talking about the general a single query where we have syntax error. Now what if multiple queries are submitted as a batch? Alright, then this whole batch is checked for any syntax errors, and the whole batch is cancelled in the event of a syntax error anywhere within the batch. So if multiple queries are submitted together as a batch to the query optimizer or relational engine, and in the event we just got the first syntax error, all of the batch gets terminated. It does not proceed further. So upon the first occurrence of syntax error, all the process gets terminated and nothing executes afterwards. So we'll talk about the multi-query query submitted as a batch. So if a syntax error is encountered anywhere within the batch, then this whole batch is checked and the whole batch gets cancelled if the error occurs, any syntax error is found within that batch. So there may be a scenario where multiple queries are submitted and we have multiple syntax errors in multiple queries. The parser stops at the very first error. So when we have multiple syntax errors, right, the parser basically stops at first error itself. Alright, and stops all the other processing. Alright, so whenever the first error is encountered, parser immediately stops the process. So basically why it interrupts the whole process just by catching the first syntax error. Basically this is the aspect of how the optimizer attempts to reduce the overhead of the optimization process. So there is no point in proceeding further if there is a syntax error within the query. So there is no point in performing any optimization. So that's why. Now, once the parsing process is complete, so when the parsing process finishes, what it generates a parse tree, right? We were showing you the structure above. So query is fed to the parser parses that query and it generates a parse key if no syntax error are found. So if syntax error are found, parser immediately stops the process, but if the query text is okay, it generates a parse tree after that. Now when the processing process finishes or gets finished, it generates a parse tree. And this parse tree is then fed to the next steps. So parse tree is then fed to object binding. So let's talk about that. The parse tree is then fed to object binding process, right? So let's talk about this binding process. What is this binding process? It uses the parse tree, right, which was generated by the parsing process, right? The parsing process generates the parse tree, which is now used by the binding process. Parse tree. So this binding process uses the parse tree to identify all the objects that make up the query. So binding process uses that parse tree generated by the parsing process to identify all the objects that makes up the query. And what are these objects? So if we say, let me take binding process to the next page. So what are these objects? This list of objects includes any tables, columns, indexes, and more. Okay, and this process is known as binding. So basically this identification of what all objects are required that make up the query is known as binding, and for that parse tree is used by the binding process to determine all the objects that are required which makes up the query. And during this binding process, okay, let's talk about the binding process. So during the binding process, all the data types being processed are identified. So our query must be using certain columns within the table, which are in turn using certain data types. So all the data types are being identified during the binding process, and maybe any kind of aggregations we are using, um, which are introduced by the group by clause, are identified. So first of all the data types are identified. Second is that all the aggregations are identified. Then what happens during the binding process? During the binding process, all these objects and processes are put together into another structure called query processor tree. So the role of this binding process is to generate a query processor tree. It uses the parse tree as input to identify all the objects that make up the query, and these objects can include any tables, column indexes, and anything more. And all the data types are identified during this process, and all type of aggregations are identified during this process, and all these objects are in turn put together to generate a structure called a query processor tree. Alright, and this query processor tree is used by the query optimizer. Alright, we have shown you the process above. So the query optimizer tree or query processor tree are fed to the optimizer. Alright, so the binding process generates the query processor tree. I hope you get the idea of binding process. You must go through the video again if you want to understand it better. So once the query processor tree is generated, it is fed to the optimization process or the optimizer. This is what was mentioned above. Yeah, it is fed to the optimizer. Okay, now let's talk a little bit about the Algebrizer, which includes the parsing and binding components. So we have just discussed the parsing and the binding processes. Now if we talk about the role of Algebrizer, it also handles the implicit data conversions by adding the steps to the processor tree. So once this query processor is generated, the Algebrizer, if we talk about, which includes this parsing and binding process, Algebrizer. Okay, so this Algebrizer components handles the implicit data conversions. Give me a moment, guys. Okay, guys, let's discuss about Algebrizer. So in addition to performing the parsing and binding steps, which we discussed before, it also handles any implicit data conversions by adding step to the query processor tree that binding process creates. And this query processor tree is utilized by the optimizer. So any implicit conversions are performed by the Algebrizer. And we also see some syntax optimizations to occur when the query text pass through the binding process. So there is some syntax optimization that happen when the query text pass through the binding process. So let me show you an example of that conversion. So I'm launching SQL Server at present. We will connect to the default instance and we will use one of the tables from AdventureWorks to the 22 database that we have installed on this box. You may download the backup file for AdventureWorks from Microsoft website and you can restore that backup. If you want to know how to restore backup files, then yeah, you may watch out one of my videos on how to restore backups in the business continuity playlist. For now, we are connected to the default instance of SQL Server. Let me trigger a new query against the AdventureWorks database. So we will talk. We are talking about the changes to the syntax as the query text goes through the binding process. Give me a moment, guys. Okay guys, let me continue writing that query. So let's do initially select star from the table name will be sales dot sales order header table we are using. Let's mark it as SOH and we are putting in where clause so dot sales order ID we are taking it between 60 to 500 and 60 to 550 we are taking. Let's execute this query. We need few columns from it, so let me put that in. So we need account number, we need order date, then we need purchase order number, and then we need sales order number. Alright, let me run this query. So this has given us the output. So basically this is the syntax for the query, and basically we see syntax optimization when code passes through the binding process under the Algebrizer. So let's try to create an actual execution plan for this. Click on this button and execute the query again. You will see an execution plan button over here. So if we click over here, and over the right hand side there is a button where you can get the query text. So let me try to copy this query text and put it there in that particular window to compare the query, the original query, with this query which is generated by the execution plan, to basically see if there are any syntax modifications. And through the binding process. So let's check that query. So if we talk about the first four columns, they are same. From clause is same. Now everything is same except the where clause. If you compare the where clause of these two queries, in the original query we are using between statement between this value and this value. Now that between is replaced by greater than equal to and less than equal to. So that is the first replacement, right? So two very distinct changes have been made. First, the between statement has been replaced with the greater than equal to and less than equal to. Second, there is a process called simple parameterization which is implemented in this query through the use of @1 and @2 that we see here, right? We will talk more about the parameterization later on. So we can see the further evidence of the binding process if we look at the execution plan generated. So in order to see that binding actually happened, let's take a look at this execution plan which is generated, right? So if you notice the first operator, which is the select operator, we see an exclamation point visible on the very first operator on the left, which is labeled as select, and this is an indication of a warning. So basically we see a exclamation point, it indicates a warning. Now if we look at the properties of this, so this is a tooltip which shows some warnings, but it disappears immediately when you move your mouse pointer. So in order to check the warning, what you need to do, you need to right click on that operator, select properties. It will open up the properties window. In the property window there is a warning section. If you scroll down, there is a warning section, so you can click on this ellipsis button to see the exact error message. So it is saying that the error message is saying, or the warning message is saying, type conversion in expression. So some type conversion is happening where it is trying to convert sales order ID to nvarchar 23. Alright, so this is the expression. So this example, if we take a look at, now if we take a look at the properties for that operator, we will see that sales order ID is actually going through a data type conversion. So if we take a look at this message, indicates to us that sales order ID is being going through the data conversion process. Maybe we can take a look at other properties as well. So yeah, we have statement, which is this, which is giving us the query. But yeah, if we take a look at error message, it somehow indicates that sales order ID is going through the data type conversion, right? Now this example illustrates several points in addition to the syntax based optimization which we saw above, between those two queries, this one and original one and the one generated through the binding process. Now give me a second, guys. Alright, let me come back. Okay, so in addition to syntax based optimization which we saw in the above two queries, there's a difference in syntax. Apart from that, first, warnings can sometimes be unclear. So this warning, if we take a look at it, it's a little bit unclear to us. So we are not sure where that if we take a look at the warning message, not sure where it is coming. So let's select the properties for this object. Okay, so if we take a look at warning messages, so it is not clear over here. So warning can sometimes be unclear from where the warning message is coming, right? In this case, a warning is not coming from the sales order ID column which we are using here, right, as referenced in the where clause. So it's, and the warning is not coming from here because the sales order ID is referenced in the where clause of the query. So from where is this warning coming which we are getting in that conversion is happening? So instead, that warning is coming from the calculation that is happening for the column sales order number. So if we take a look at that table under the AdventureWorks 2022 database, if we take a look, let's go to sales order header table. If we expand the columns, we have this column sales order number. So this is the number and this is a computed column. So this is resulting in conversion of that sales order ID values. So if we take a look at properties of this, and this is the formula where it is converting the sales order ID over here, right? So it's converting the sales order ID. We can check it again. So if we just point our mouse pointer over here, it is saying that it's converting sales order ID into nvarchar 23 type. Alright, so that is what is happening, and that is what resulting in that error message or the warning message. So the conversion is coming from the calculated column sales order number, this one, and that calculation is converting the sales order ID, which is an integer value, into a string, nvarchar 25 or 23, whatever is written over there, and adding other information to it. So in this way the calculation is being done. The optimizer recognizes that, well, this to be used as a, if this calculation has to be used as a filtering criteria, So here optimizer is assuming that it is using that calculation, which is conversion happening, is being used in the where clause, right, or join criteria, or in the having clause. But here it is assuming that that conversion is happening in the where clause, right? So if it's actually happening in the where clause, it would have affect the performance. It would affect the ability to use statistics and indexes to get good performance. But in reality, the actual conversion is not happening in the where clause. So in where clause, we just have sales order ID column, and here the conversion is not happening. But the conversion is actually happening in the background because of this column. But in where clause, we do not have any direct conversion of the sales order ID column. So this one is fine, right? Now in this case though, the query doesn't reference the column in any of the filtering criteria, so we can safely ignore the warning. So this warning can be ignored because that conversion which it is indicating, the warning message showing conversion which it is indicating in the warning message, is not happening in the filtering criteria or the where clause or some join clause or some having clause. So alright, so we are fine over here. We can safely ignore this warning. Now, unlike the data manipulation language, let's go back to notes. So unlike the data manipulation language, we are done with the binding process that basically creates the query processor tree. Now we are talking about, unlike the data manipulation language queries that we have seen so far, data definition language queries such as create table do not get. So here is a huge difference. Let me write another point. So unlike DML statements, so select is also a DML statement. If we say select is also a DML statement. So unlike the DML statement queries, the DDL queries or data definition language queries, maybe such as create statements, where we use maybe create table statements, do not get execution plans. So we cannot get execution plans for these type of statements. The data DDL language type statements or DDL queries, we do not get any execution plans. Therefore, most DDL do not go through the. So if we talk about this, okay, I need to. Okay, so we can say that most DDL statements do not go through query optimization or do not go through the optimization process. The exception to this is create index statement specifically. So create index statement goes through the optimization process. Alright, so the optimizer can take advantage of existing indexes to create another index more efficiently. Okay, let me mention that. The optimizer can take advantage of existing indexes to create another index more efficiently. So this is an exception. The optimization and this create index statement goes through the optimization process, whereas any other DDL statements like create table statement or anything else doesn't go through the optimization process. So for example, we can never see a create procedure execution plan, but we do see an execution plan for create index statement. Alright, so I hope you get it. And once all the binding operations are complete, so when the binding operations are complete, we get the query processor tree. Now this query processor tree is fed to the optimizer. Now at this point, once the query processor tree is generated, the optimization process starts. So we will cover the optimization process in our next video, guys. So far in this video, what we have covered, let me take you through that quickly. So we have talked a little bit about query optimizer, its use. Its use is to create execution plans, and it's a very important component. And then we talked briefly about the optimization process. Then we discussed a little bit in detail about the query optimization process. So what the query optimizer does during the optimization process, we have discussed about that. Then we discussed about the optimization preparation plan, starting from a query that we write, how it passes through the relational engine, then through the storage engine. And relational engine includes the Algebrizer process, and Algebrizer process contains the parsing and binding steps to create the parse tree and the query processor tree. So far we are done till here, and in the next video we will be covering the optimization process. So we will talk about the how optimization happens and how the execution plan is generated and fed to the storage engine to access data from the tables. We'll talk in detail about that, so stay tuned guys. If you have not already subscribed to the channel, and if you are a new user to this channel, I would highly recommend immediately subscribing to this channel. There's a subscribe button below this video. Click on that subscribe button. You will get a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my future videos. Also, if you like this video, please click on the like button. And if you have a good network of friends, please share my video with your friends in case they are working in SQL domain, or if they are using SQL in any way in their day-to-day lives, or if you think my videos will be useful for them. Also, please ask all your friends to subscribe to my channel in case they are working in SQL domain. Guys, I thank you so much for your time on this video today, and you have a wonderful day ahead.